guys, so I'm going to get started with this next sort of presentation. One of the things that becomes important for you guys to sort of understand about analyzing and studying architecture, right, especially in a survey history course like this, is that there are certain things and reasons that architects and designers use as devices for how they create buildings. All right. And so I did not create this PowerPoint that we're about to look at. This PowerPoint was created initially by Professor Robert Perkins, who retired, and then it's been modified by Professor Fields, and I sort of picked it up. What I did is I took that PowerPoint that Gail gave me, and I broke it up so that it's not this long 60-slide thing. I broke it up into different sort of topics. Okay? So right now, what I want to talk about is one piece of that larger PowerPoint called Key Architectural Concepts. Okay? So can you guys see the screen okay? No problem? Do I need to darken the lights or anything? No? Okay. So there's a variety of different things that you guys kind of got to think about that will create a frame of reference. It will create a framework for you guys to analyze the buildings that you're looking at. Okay, so one of those things is partie, and partie is a French word, right? And what it means is an organizing idea for the building. Okay, it's the big idea for the building. A second thing that you guys are all going to have to, and let me pause for a minute in this discussion. It's important that you guys understand what these phrases are, okay? Because later on, you're going to be asked to analyze some of the buildings that we're going to be reviewing in class. And your analysis is going to be based on some of these points and a few other things that I'm going to talk to you about. Okay? All right. So we already talked about partie. The second thing is form and geometry. All right? So form and geometry are important to the design of buildings because they all obviously have a shape. That's the form part, right? And the geometry is the thing that sort of gives that form a structure. So there's going to be different ways to classify forms. We're going to go through it initially with the ones that were developed as part of this PowerPoint, and then I'm going to add to that from sort of my perspective on things. Okay, the next thing is scale. How big is something relative to some unit of measure? Now, the best thing that I can do in approaching this is to make all of you do an exercise that I make my design students in Design 1 do now. And that is, and we're probably going to go ahead and do that. Maybe we'll do it today. All right? We're going to go through this process of photographing our bodies. Okay? So probably take you guys somewhere and stand you up against a corner or something and make you stand with your hands outright, right, like the Renaissance man. And take a photograph of yourself, and then you're going to start to take some key measurements. How many of you guys know the relationship between your height and the distance between your fingertips? A few of you do. So one of the things to realize is that I'm 6 feet tall, and from tip to tip of my fingers, I'm about 6 feet. So the width of your outstretched arms and your height are going to be pretty close to matching. And there's a few other things that you guys got to know about that sort of condition, because you understand the world in relationship to you, right? If you're standing here and a little kid comes walking up to you that's about a little taller than your knee, you kind of see that person as a little person, right? If someone like, Shaquille O'Neal or one of these giant basketball players were to duck under that thing and come inside, and they're standing here and they're like 7 foot 8 inches tall or something, you're gonna compare that person to you. You guys have all now walked into this building at least twice, right? You get a sense of how big and how tall the corridor or this classroom is, right? How many of you have walked through that main entrance? Well, most of you have walked in through that main entrance, right? The main entrance, is it pretty big and tall? It is. You perceive that, right? It's big and tall. Your mind's saying, hey, this is big and tall. It's not big and tall compared to the Empire State Building. It's not big and tall compared to an ant. It's big and tall compared to you as a person and your body. So that becomes a key thing that you guys need to understand is scale. All right? The next thing is proportion. So proportion is the relationship of parts to the whole or different parts to each other. Elements taller than they are wide are referred to as vertical. Elements that are the opposite are considered horizontal. Okay? Proportion also, that's not in this slide, but it needs to be in your notes and in your mindset. Proportion is also considered to be a ratio. Okay? A ratio. So let me ask a question. When you guys look at this room that you guys are sitting in, right? What are the proportions of this room? What would anybody want to venture a guess?
2 to 1.
I would say not. I mean, one way you can do it is by counting the tiles. The tiles are 2 feet. So we could do that right now. We could say, all right, let's go 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, and then a half and a half, so we'll say 19. So this room is 19 tiles wide. That's our unit of measure. The tiles are actually 2 feet, right? So 2 times 19. Now we'll go from front to back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. About 16. So in my mind, the immediate thing I thought is the room's about 1 1/4 to 1. It's not square. I can tell that. I can tell it's longer this way than that way. Right? Right now we're just looking at the floor dimensions. How about the hallway? What's the ratio of that? Well, the ratio of that's, probably 10 to 1. It's probably 10 times as long or 8 times as long as it is wide. And so understanding that becomes an important part of understanding what proportion is. Okay? So the way that this one's written, it's about what you perceive things when you're looking at them from, say, the front, right? Vertically. Is it a horizontal massing or is it a vertical massing? But proportion goes deeper than that. Axis and symmetry, and I just noticed, I believe axis is misspelled. I think it's an I. Yeah. It's axes and symmetry. Elements are sometimes balanced around a central axis. And I'm going to try and talk to you guys a little bit about points and lines, okay, at a different time. But axes and symmetry are an important feature that you guys need to analyze in every building that you look at. Because the architect that designed those buildings was thinking about those things when they made them, okay? And I've got, all of this is just kind of an introduction with some quick definitions of stuff. Path and circulation, right, is about how a user moves through a building. So for example, we use this building as an example, right? So the rooms that are being used are two sides of a long skinny corridor. There are 2 long skinny corridors, one on that side of that big tall space and one on this side. And so the path of this building is these 2 corridors that meet in this big tall space in the middle, and that big tall space in the middle is how you go up and down. And there's also ways to go up and down on the ends. So understanding the path and circulation of any building is important. How many of you have ever gone to a cathedral? So a few of you have been to cathedrals, right? And so when you approach a cathedral, right, you come into this first initial space, but when you walk into it, there's generally this path that runs through the cathedral, depending on what kind of cathedral it is. And that path leads you to the nave and the crossing and a number of different liturgical things that are at the other end. right? And when you look at cathedrals, incidentally, great, the thing just went to sleep. Come on. And we're back. Okay, so when you look at cathedral, right, if you look at the ancient cathedrals or the old cathedrals, there was the nave, which is the middle part, but then there were always two side aisles. And the expectation was that when people entered, they would walk to the side aisles. So understanding the path and circulation of buildings is crucial. All right? And finally, enclosure. What's the relationship of the spaces in and around the building to the outside world? Does the building have like these porches that are covered, but if it's cold outside, you're cold? Does it have interior rooms that are completely enclosed? Does it have interior rooms that are open to the sky? Understanding the level of enclosure becomes kind of a crucial thing in trying to analyze architecture. Click, click, click. No? Ah, wait, I didn't push the little F5 button. There it is. Okay. All right, so now let's go a little further into depth into this idea of party or organization. Okay, so an organizational method. This comes out of Francis D.K. Ching's book Form, Space, and Order, right? Can be considered to fit into a few different categories: centralized forms, grid forms, radial forms, linear forms, and clustered forms. Okay, and I can expand upon those a little bit as we go further through the semester, but those things tend to be the organizing principle. When you look at buildings, you're going to look at them and say, oh yeah, there's a clustered arrangement, right, or a centralized arrangement of spaces at one end of that structure. So here's an example of a temple in India, and this is an example of a linear arrangement, right? There are a series of spaces that are arranged in this line. Okay. This is a project I think by Toyo Ito. I was going to say Shin Takamatsu, but and the idea for this project, right? There was this conceptual partie of these elements that sort of, this is more contemporary architecture, not what we're going to be studying for the most part in this class. But the idea was that these pieces would flow between the levels of the building and that they would act as light wells and connectors between the spaces. But that led to the form of the building. And you can see Ito's initial sketches on that side, and you can see the finished building sort of on this side. The idea of symmetry. Okay, so symmetry, all of you pretty much mastered the notion of symmetry when you were about 5 years old. Okay, it's not a hard concept to understand. Our bodies generally are symmetrical. One eye on this side, one eye on that side. Half of my smile's over here, half of my smile's over here. I have an ear and an ear, right? You draw a happy face. You guys could do that when you were kids. You could draw a Christmas tree. You could draw a little house, the door in the middle and two windows, and a chimney right in the middle where it normally wouldn't be. All that stuff you mastered when you were like this big. All right? So it is, when you look at ancient architecture, it is kind of the overriding principle for the most part. There are deviations from it. In the modern world, the opposite of symmetry is asymmetry. One thing that you guys probably should understand is that you can create balance with either symmetry or asymmetry. I don't have the props here, but I used to do a thing with my design students, and I'll draw it up on the board. That thing can still hear me, right? Yeah. All right. So this notion of symmetrical balance, if I think of it in terms of a fulcrum and a beam, if I put a weight on either side of that, most of you would look up there and say, yeah, that's balanced. An equal weight on either side of that symmetrical fulcrum. But if I choose to do something on the lines of this, both physically and visually, that can also imply a sense of harmony and balance. Okay, because the lever arm is so much longer on this side, a very small weight can balance a very large weight on a shorter lever arm. And that works visually as well as physically. You guys can actually do this. You can create a balanced beam and put that thing up there. Okay, so I'm going to back up for just a moment here to this stuff here, right? Because if you guys didn't take notes on this, it's kind of important that you quickly jot these things down. Otherwise, as we go through the different parts of this lecture, you'll get lost. Okay? So just quickly write down partee, form geometry, scale, proportion, axes, use an I instead of an E, path, circulation, and enclosure. And just kind of keep those to the side as a reference. Okay? So we started with partee, then we went to symmetry. That was the second thing. And now we're on the third item, which is form, right? What is the overall form of the building? And in simple terms, it's not always possible to do this, especially not with contemporary structures. You can look at the form of a building and say, it's a box, it's a drum, it's a sphere, it's a pyramid, right? So you guys can kind of see those initial basic shapes. And you're going to see those initial basic shapes in a lot of the architecture, if not all of the architecture, that you're going to be studying in the class. So this is an idea of, not an idea, but this is an image of the Colosseum in Rome. I was fortunate enough to go see this building a few weeks ago, and it's kind of creepy. Huh?
To scale?
It's massive. It is so
No, but him personally.
freaking big. It is just crazy that this thing was built that long ago.
You said it has all the orders in it?
It has 4 of the orders going up to the top. So the bottom is Etruscan, the second order is Ionic, the third order is the Corinthian, and then the composite order, I believe.
Why did you do that?
Are you able to see it?
Just
You can see it when you're there, yes. So, and I probably have images that show that. What you're seeing is not what the Colosseum looked like. So, but anyway, let me keep going. So the Colosseum is essentially this big drum. Okay? And like I said, it's creepy inside. The guy that was talking, he was discussing it, he was talking about how they had to, at times, burn incense. They had this thing that they would float around that would have incense in it because the stench of the blood from all of the dead bodies and animals and stuff would get so intense that it would nauseate people. Yeah, very creepy place. At any rate, you can also take form and we can sort of start to break it up. We're looking at geometric form, which is basic geometries. That was the things I mentioned a minute ago, a cylinder, a pyramid, a rectangle, a sphere, any number of those basic forms. In addition to that, you can also think of form and you can describe form as an additive or aggregated object. Okay, so that's not in the lectures, and so believe me, this young lady right here takes extensive notes, and she's going to look for all the stuff that I'm mentioning that's not in here to make sure that she asks a question. That's a good one. All right? So in addition to using the word additive, you can also think of it as aggregated. That means brought together. Okay? A different way to kind of look at form is as a subtractive form. That is, you had an initial large thing, and you scooped away at it to make something else. When Michelangelo or Leonardo da Vinci or one of the great sculptors would have a giant slab of marble or a giant chunk of marble dropped somewhere, they would chip away at it to kind of reveal the form inside that they were thinking of, right? That's subtractive form. And finally, you know, there's a different way of looking at it that could be a biomorphic form or an organic form. All right? Those are very different than the Euclidean forms. What is Euclidean? It's based on Euclidean geometry, right? Circles, lines, definable things. Nowadays, we have these things called NURBS, right? Non-uniform resource something or other. Non-uniform rational B-splines. Those things are not definable. Don't worry about that one. You don't have to worry about. So, but those things create these kind of organic shapes. If you've ever drawn lines in like Illustrator or one of these programs, right? The lines that you can create by grabbing those handles do not have center points. They work off of a chain of things. Those are organic shapes. All right. So here you see, part of ancient Rome. You see the Colosseum. You see the Circus Maximus. You see a number of different sort of things, and you can kind of take a look at the fact that the pieces kind of relate to a cylinder, a pyramid, a cube, a rectilinear solid, or a sphere. Okay, and you can see a variety of those things in the ancient map of Rome. And I actually, when I was in Rome, for you guys, I bought this great big old map that basically somebody modeled all of Rome, right? What it was like to actually look at it from like an aerial view. I'll bring that thing in. Or actually, I might have it right here. Yep, there it is. Haven't even opened it. I literally was thinking of you guys when I was walking down a street in Rome. Walking up from the forum, I thought, I'm going to buy this for my architecture students. You want me to take you there, huh? Oh, that's good. Yeah. So I was quite amazed when I saw this sitting on this shopkeeper's wall, because I'm like, holy cow. I could not imagine an ancient city of that scale. I would have thought, Rome, it's a few blocks or something, or maybe 20 or 30 blocks. But the way this map is set up, it's supposed to be a recreation of the city of Rome, and it's mammoth. No, it's all right. It's getting really long, huh? Yeah, I better stop the video. I will stop the video, but there it is. There is the this kind of 3D view of what it was like to walk around when, I don't know, Alexander the Great was the Caesar. You were asking about the orders?
Yeah.
This is a recreation of the Colosseum as it looked before it was destroyed. All right, so guys, I'm going to stop this video because it's getting too long.